Hi dear students, welcome back to computer science class. In our previous session we have seen recursion and its example, and for today we have one more example for recursion and a comparison between recursion and iteration. You know what recursion is? Recursion means a function calls itself. Okay, now let's see another example, one more example for recursion. Here we are finding the sum of first n natural numbers using recursion. Here is the block of code. We can start with num equal to int of input of enter number. With this statement, we can initialize num with any value. That is, suppose we are inputting what value 6 to num. You know what int is? Int is by default Python receive value as a string. It should be typecasted to what integer type. Okay. So num stores integer value 6. Then we are calling the function recursion. Okay, that is our function. Print the sum is recursion, and we are passing the value of num, that is 6. 6 is passed. Okay, so it is passed to the function header. Here the formal parameter is n, and n gets a value 6. Then it checks n. 6 is less than or equal to 1. It's not equal to 1, less than or equal to 1. Then it moves to else. Return n plus recursion n minus 1. You know what it is? Recursion of n minus 1. It is another function calling statement. That is what actually recursion is. So here the value of n is 6. So in effect it is 6 plus recursive sum of n minus 1, that is 5. You know, recursion is another function calling. At the time control passes to what? The header part recursion, and n gets 5. And it checks 5 less than or equal to 1. It's not. Then moves to else. Then here it is, the value of n is 5. 5 plus recursion of n minus 1, that is here at present the value of n is 5. So 5 minus 1, that is 4. Recursion of 4, it is another function calling. It moves to the header and it checks what, then moves to else. So here it is 4 plus recursion of n minus 1, that is 3. Recursion of 3 is another function calling. It moves to header part, it gets 3. It's not equal to, so 3 plus recursion of n minus 1, that is 2. Then again to the header, it gets 2, n gets 2. 2 is not less than or equal to 1, moves to this. Then 2 plus recursion of 1, n minus 1, that is 2 minus 1, 1. Okay, recursion of n minus 1, that is 1, and recursion of 1. Here n, the value of n is 1. 1 less than or equal to 1, 1 equal to 1. At the time it returns what? The value of n, that is 1. We got the result for the last function calling. Okay, we know we are using a stack to perform a recursion operation. So for the first function calling, the status of stack will be 6 plus recursion of 5. Recursion of 5. You know, recursion of 5 is another function calling. At the time it moves to what? Yeah, 5 plus recursion of 4. But we know one thing, 6 is already here, but we are not writing it. Okay, 6 is already here. The same way for the next it is 4 plus recursion of 3 for the next one. Here for 4 we know it is 6 plus 5 plus 4. Okay, so next is 3 plus recursion of 2, then 2 plus recursion of 1. When the function is called by passing the value 1, it returns what? 1. So we know the result of recursion of 1 is what? It is 1, because when n gets 1 at the time of executing what? Comparing n minus 1 n less than or equal to 1, it is 1 equal to 1. At the time it returned 1. Then the result of recursion of 1 is 1. So 2 plus 1 is 3. Okay. Then okay, this we know it is a stack, so this will be popped out first. 2 plus 1, that is 3. That is 3. We know 3 is the result of recursion of 2. So 4 plus what? 3 plus 3, that is 6, will be the result of that function calling. We know stack follows what? LIFO, last in first out. Last input item can be taken out first. Then recursive sum of 3. The result of recursive sum of 3 is, we got it as 6. Okay, 6 plus 4. Yeah. the same way this will be popped out, and finally the last item will be popped out and we get the result. Okay, so that result will be returned to recursive sum of what, to the sum is recursive sum of num. So this is how recursion works, and we have seen 2 implementations of recursion. Now hope you get the idea. Okay, so this is about recursion. Okay, next we can look at the comparison between recursion and iteration. It is recursion versus iteration. We have seen both recursion and iteration in detail, and now let's see the differences and some kind of relations between recursion and iteration. We know in programming, recursion and iteration are interrelated concepts or interrelated techniques of solving problems. And we know a problem which can be solved using recursion can also be working somewhat equally well with iteration. So but there is a subtle difference between recursion and iteration, and we are going to look at that. Okay, so when a loop is executed repeatedly, it uses same memory locations and same unit of code. Instead of using same memory locations and same unit of code, recursion uses fresh memory space during each recursive call. That is the main difference between recursion and iteration. Iteration uses same memory locations and same unit of code, but recursion uses fresh memory, which allocates fresh memory to each recursive call. And we can see recursion. We know a problem works somewhat equally with recursion iteration. A problem which can be solved using recursion can also be solved using iteration and vice versa. But recursion uses fresh memory location, as we know, plus there is an additional cost in terms of RAM, in terms of memory space used by RAM. Okay, so recursion need additional cost of memory in terms of memory used by RAM to process each recursive call. And this recursion takes extra space because recursion works on stack manipulation. So to process a stack, it needs extra memory. It makes recursion somewhat slower and having more memory. Then it's up to the programmer, and it's based on the problem we are making use of either recursion or iteration. It's up to the program. It's up to the problem which one to be used. Okay, for the programmer to decide which is the either recursion or iteration to be used to solve a problem. So these are the comparison between recursion and iteration. As we see, recursion and iteration are 2 interrelated concepts, and both functions somewhat same, but there is difference between recursion and iteration. During each execution of iteration or iterative process, it uses same memory locations and same unit of code, but recursion uses fresh memory during each recursive call, plus it uses extra memory in terms of memory used by RAM to process each recursive call, plus extra memory space used for stack manipulation, because recursion works on stack. We have already seen it. So it takes some more memory. Additional cost will be consumed. Okay, additional memory will be consumed, so it results in additional cost, of course, and it makes the program somewhat slower and taking as it takes more memory. And we know, as we see, it's up to the programmer, and based on the problem we are deciding which one to be used. Okay, so these are the differences and similarities between recursion and iteration. Thank you for watching.